Springs store energy, and that stored energy scales in a sneaky way. So let's see 3 examples. First, a spring shoots a cart, stiffness 600, squeezed 15 centimeters, cart mass 1.2 kilograms, starting from rest. We want the energy stored and the cart's speed the moment the spring lets go. Stored energy is 1/2 times k times x squared, 1/2 times 600 times 0.15 squared, which is 6.75 joules. On a frictionless track, all of it becomes motion. 1/2 mv squared equals 6.75, so the speed is about 3.4 meters per second. Notice the spring force is k times x, so as the cart moves out and x shrinks, the push fades to nothing, strongest at full squeeze. Next, a spring launches a block up a frictionless ramp. Stiffness 800, compressed 25 centimeters, block mass 2 kilograms. The stored energy is 1/2 kx squared, 1/2 times 800 times 0.25 squared, which is 25 joules. All of that energy lifts the block. 25 equals mgh, so the block rises about 1.3 meters. Now double the compression to 50 centimeters. Energy grows as x squared, so it jumps 4 times to 100 joules, and the height to about 5 meters. Last, a block sits between 2 springs. The left one, stiffness 300, the right one 700, pulled 20 centimeters to the right. The left spring is stretched. Its stored energy is 1/2 times 300 times 0.2 squared, which is 6 joules. The right spring is compressed, the same amount. Its energy is 1/2 times 700 times 0.2 squared, 14 joules. Add them and the block stores 20 joules in total, exactly 1/2 of the combined stiffness times x squared. So remember, elastic energy is 1/2 kx squared. It turns into motion or height. It scales with x squared, so doubling the stretch quadruples the energy, and 2 springs each store their own share. Subscribe to Ox Learning for more physics like this.